again, as I said, we're starting a new unit on similarity. What we're going to work on today is using the cross-product property to solve proportions is really what we're looking at. You probably already know how to do this, but it's usually under a different name. It's called cross-multiplying. And we actually covered this, my classes cover this in a lot of detail in Algebra Geometry 1. And you probably also covered this in 6th grade, 7th grade, and 8th grade. So probably today is a very, very easy day for you. But I do want you to follow along because maybe you can glean something new or get something new out of this. One thing that might be new to you is kind of the ideas of extremes and means. Okay? So if you think of mean, mean is usually like the idea of like an average or something that's in the middle, right? So mean is like in the middle. Average is something, some number in the middle kind of thing. An extreme, you can think of something like if you taste something and it tastes like either extremely good, like, oh, that's so delicious, like a raspberry, or, that's so disgusting. I guess you would say, you say, oh, it's so disgusting, like it's extremely bad, like rotten milk or something like that, okay, like it's curdled, yeah. So the extremes are either like the very top, like, best thing or the very bottom worst thing, right? Or it's the very first thing and the very last thing, something like that. So when we see this, we see an equation here. This is technically a proportion. There's a ratio on the left side and a ratio on the right side. Two ratios set equal to each other are called a proportion. Okay, so that's kind of an interesting kind of a word for us, a proportion. A lot of people will misspell this word. I wonder if it's misspelled right now. A lot of people will write this way. They'll say proportion, which is not the correct way of spelling it. So watch out for that. It should be proportion. Oh, proportion. Make sure you spell it correctly. It's proportion. So two ratios set equal to each other is called a proportion. This is a proportion here. A over B equals C over D. And what's the very first thing that I said when I said A over B equals C over D? What's the very first thing? A. What's the very last thing I said? D. So those, the very first and last, are called the extremes. Okay? The things in the middle, things that I said second, are second and third, I guess, are the mean things in the middle. Okay? That's kind of the way that I remember it. So B and C are the means of the proportion. The numbers A and D are the extremes. So when I say it out loud, the things that I say first and last are the extremes. And the things that I say in the middle, the B and C, are the things that are in the means. So again, if we were to cross multiply, it's something like this. These are the extremes. These two are called the means. Is that okay? Because you're going to be able to remember the means and extremes? Yep. Okay. So let's complete the table. I calculated the products of the means and then calculated the products of the extremes. Again, the means are the guys in the middle. That's these guys here. And you probably will need a calculator for this, for some of them. Justin, what is 5 times 6? 30. So we're going to write 30 as our product of means. Brett, what is 2 times 9? 18. And let's see, Sierra, 8 times 28. 224. That sounds good to me. So these are our means. The extremes are going to go the other way. There are these guys here. So let's see after Sierra. Tyler, Cox, 3 times 10, or 30. Sounds good to me. Let's see. Lauren, 6 times 3. 18. 18. That's kind of a nice number there. And then let's see. Nicole, 7 times 32. Probably 224. That's a really good guess. If you were guessing 224. Okay? It says below here, let's draw some conclusions. Okay? Use your observations to complete the following. What do you notice about these? They're all the same. So your product of means equals your product of extremes. It's probably what I would write here. What do you observe about the product of means and the product of extremes? I would say something like the product of means equals the product of extremes. And I would be using a complete sentence. The product of means equals the product of extremes. Okay? So the product of means equals the product of extremes. That is using a complete sentence. I'll say it one more time. Hopefully you're going to write it down this time. The product of the means equals the product of the extremes. That's a huge concept when we talk about this, and it's before we had this, we don't even know what means or extremes meant. Now all of a sudden we're writing a sentence about it. I'm a pretty smart guy. I've taken a lot of classes on education and what helps me to be a better educator. And one thing that does really help is actually writing things in sentences. There's an idea of sort of understanding something enough to be able to just kind of know what to do. But I think it actually takes it to a different level and actually helps you to understand it more long term if you can actually somehow either say it out loud or write it in a sentence. So sometimes I'll be on you guys to say, like, what do you do? Oh, well, you just multiply them, or you just subtract them, or you just do whatever. But sometimes I'll sort of drag it out and I'll say, what do you actually do? What are you actually doing? Explain it to me. And the reason is because if you can actually explain it or write it in a complete sentence, you actually are able to retain it and actually keep it longer as opposed to just having some skill and then forgetting all about it for a while. This is a cross products property in a proportion. The product of the means, blank, the product of the extremes, what are we going to write there? Equals. Okay. Equals. So we're basically writing the same thing kind of twice, kind of in two different ways. One is actually the cross products property. Again, I always forget what this means. I think it just means basically cross multiply. Any questions on this? The product of the means equals the product of the extremes. Okay? And here's how we're going to use it. Number 3. Is this on the back side? Okay, this is on the back side. It says calculate the cross products of the given proportion. So the product of extremes is basically just 2 times 20, which is 40. And the product of the means, that would be these two, would be 5 times x equals 5x. Is that the same thing as saying 5x equals 40? If you would have written it the other way, is that still fine? Yeah. That's all we're going to say. It says calculate the cross products of the given proportion. Whenever you see a proportion, one ratio equal to another ratio, you can automatically write this. This is a true statement. Okay? Number 4 says explain how you can use the cross products property to find a missing value in a proportion. Write an example like the one in number 3 and solve for the missing value. So the very first thing, let's just focus on this. Explain how you can use the cross products property. Why don't you guys take 1 minute and actually explain, maybe use 2 complete sentences, and explain what you need to do in order to find a missing value in a proportion. Try to write it down. It's kind of a challenge. I haven't really had you guys do this yet in here this year, but let's try this. Just actually write down some sort of sentence or 2 sentences on what you would actually do in order to solve for a proportion. When you're done with it, put your pencil down so I know that you're done. And when you're done, just put your pencil down so I can kind of see what's going on. Okay, here's what I want you to do. Not everybody's finished. I'm going to just explain the instructions as you're finishing up whatever you're writing down. I want you to actually exchange with the person next to you. I want them to read over whatever it is that you wrote down for number 4. And it might not be good, okay? It might be okay, it might be okay. And what I want you to do is I want you to read it over. And if they don't have anything, obviously you need to just hand it back to them because they need to write something down, I guess, still. And I want you to read it over. And I want you to see if there's anything that you could add or correct or change or something else that you would write. Just write it right next to theirs. Again, you guys are looking at number 4. You're reading the person's next to yours. Maybe if they did really good, write, hey, that sounds good, or whatever else. But if there's something you want to change, letting you know you can use the cross products property to find the missing value. Okay. Does anyone need more time for this? All right, why don't you pass it back to the person next to you? Pass it back so you have your own paper back. Read over any comments that they may have given you. Does anyone want to share just the answer to this first one? Explain how you can use the cross-product property to find the missing value in proportion. Just raise your hand. Someone want to volunteer their answer, just whatever they wrote down. You can just read off your paper, it's not that tough. Sierra, what did you have written down? Okay. 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 So you were basically starting here at this 5x equals 40. You're going to divide one side by the other. That sounds pretty close. Maybe it's not as precise as it might need to be, but I think that's close. I think you have a general idea of what's going on. I don't think I'm going to get all three of you. We'll start with Lachey. We'll do over here.
Okay, I like to off the bottom up there.
Okay. So what did you say?
Apply those strings that I have, both positive strings, get to that total by the number times the extremes.
There you go. So what she said is basically multiply your means, multiply your extremes. So those equal to each other in proportion. Okay, so that's where we're at. And then divide the number that's by the x on both sides, and you'll get your answer for it. That sounds good, Brett. Okay. Do you want to say? Why don't you say in your own words? Just make sure it makes sense.
Multiply the means with the extremes, and then divide that number by the.
Wait. Say that again. The very first thing.
Multiply the means with the extremes.
Did you say or the extremes? Well, they give you both. You need to multiply both. Like the means would be 2 times 20 equals 40. So you have to multiply the means as you do those the extremes. And the means multiply those together, so 5 and the x. Set them equal to each other. Then divide. Okay. Hannah, what'd you say? That sounds really close. I think you said multiply the number with the variable, or divide the number with the variable by the other number. I think it almost needs to go the other way around. Because you'd say divide 5 by 40. That's not what we want to do. Or divide 40 by 40. I think it was good to be able to write it that way. So that's pretty good. If you need to change yours now, why don't you guys change yours for number 4? Change it. And after you're done changing it, it does say write an example like the one in number 3 and solve for the missing value. And you can make up anything. As long as it's a true statement, it should be fine. You're going to write some example, and you'll solve it. So what most people are saying for this first one is you multiply the means, which is 5x. You multiply the extremes, that's 2 times 20. You divide both sides by 5. You get x equals 8. Okay? That's the process we're going to go through. Is basically we're going to cross multiply. I like the way you said that. The means times each other. Have that equal to the extremes times each other. You're writing an example, and then you are actually solving it. And you've been doing this for a long time, because sometimes people would give you something like, 8 30 seconds and say, can you simplify that? Well, yeah, you can. Like you're like, oh, let's get it to fourths. That's an x. So you would multiply these out, you'd have, 8 times 4 is 32. 32 times x is 32x, divide both by 32, and x equals 1. Okay? That's kind of one way to solve this. Doing the other way, sometimes they're like, okay, well, we have 1/8. We're going to add that with some other number, maybe like 16ths. You're like, well, how many 16ths is 8? Well, it's 2. It's kind of the way to solve that. If you don't know how many 16ths you want to get this is another way of doing it. It's just you're doing a lot of it in your brain. Somebody have an example they want to share? Example, let's see. Connie, what's your example? Oh, okay, so we did this part, but it says write an example like the one in number 3. Did you have one of those? An example? No, you didn't. Okay, well, you can write one right now. It's fine. Rashad, what's your example that you had?
So would we just like write a problem?
Okay, yeah, there's two sentences here. The first thing says to explain. The second sentence here says, write an example like the one in number 3 and solve the missing value. That's all right, Rashad. You can write one of those right now. Well, that's okay. Well, we're gonna go with Maddie. Maddie, what's your example? 7/7 equals x over 2. Well, that's gonna be a good one. Oh, over 4. Let me change that. Sorry. X over 4. That's gonna change the answer. So you cross multiply. 7 times 4 is 28. 7 times x is 7x. Divide both sides by 7 and x equals 4. I think that's a good example. It's a really easy example, but it is a good example. It does work. And that works. That's fine. That's okay. That happens sometimes. Sierra, let's do yours as well. Sierra, what's your example?
I put 27 over 6. Wait. No. Oh, I'm sorry.
Okay. Well, I'm going to erase that.
3 over 6
3 over 6, so that's like 1/2. Sure.
equals x over 9.
X over 9. Okay. So you got 4.5 in the answer. Is that right? Okay. So you multiply 3 times 9, which is 27, equals 6 times x, which is 6x. Divide both sides by 6, and you can get x equals 4.5. It's totally fine. Sometimes we'll get decimals, and that happens. It's totally fine. Anyone else want to share their example that they had? Well, if you don't want to, we do have some examples that we need to look at here. Let's look at number 5. Yours are crunched together kind of a little bit too much here. So I kind of spread them out a little bit. It says use the cross products property to find the value of each proportion. Let's go with Silas. How do we do number 5?
39x.
39 times x, that's multiplying your extremes.
Equals 117.
Equals 117. So that's probably 13 times 9, I take it, right?
Yeah.
Then what'd you do?
I just did 117 divided by 39.
Okay, so you divide both sides by 39. This is showing all your work for it. Okay. What'd you get?
X equals 3.
X equals 3. And you probably circle the x equals 3, right? And it's legible. Everybody can read it. Perfect. And you circled the x equals 3, right?
Yep.
Excellent. Number 6. Let's go with Tucker. Number 6. What'd you do? What'd you get? Okay, let's multiply the extremes. Okay. 192. Okay. 24 and 24. X equals 8. And you circled it, and everything's good. Okay, that sounds pretty good to me. Tucker, let's go with Sam. Sam, what do you want to do for 7?
7. 5x.
5 times x, it's multiplying the means.
Equals 48.
Equals 48, which is 2 times 24, which is the extremes. Got it?
And then you divide 5 by 24, which gives you 9.
Whoa. What you said is divide 5 by 24. Is that what we're doing?
24 by 5.
There you go. Now you're saying it correctly. Good. You just got ahead of yourself there, okay?
And then that equals 9.6.
X equals 9.6.
It's 48 divided by 5.
Oh, 48. That's I wrote down 24. I don't know why I did that. Okay. It's 48
Yeah.
divided by 5. 9.6. That sounds pretty good to me. Is it okay that's a decimal? Should we say it's 10? No, because 10 is not going to work. Okay? It doesn't need to be 9.6. That's fine. Now, you guys don't have these other examples written down, do you? The ones I have written in blue. Why don't you guys write them down really fast? And they're kind of written differently. So I need to explain these just a little tiny bit. These are written in what's called ratio form. Ratio form. Well, this is what I would call them anyway. It's called ratio form. It's a little bit different because ratios can be written either as a fraction or ratios can also be written sort of with the colon. Okay? So if I was to have this was 9 over 39. Another way to write 9 to 39, another way to write it is 9 colon 39. Okay? So 9:39 is the same thing as writing 9/39. It's the same thing. So if I was to think about this, this really just means, it means 5/10 equals 10/x. It means the same thing, but it's not written the same way. Okay? These mean the same thing. 5/10 equals 10/x. It means the same thing. Okay? So you can either think about it this way in your head, or you can physically write it down, that's fine. Or you can actually just work it out in the same way. In this case, your means are the things in the middle. Those are your means. And your extremes are going to be the guys on the outside. Those are your extremes, which actually makes a little bit more sense with the definitions that I gave you. If we're going to multiply the extremes, what's 5 times x? 5x. You're multiplying your means, what's 10 times 10? 100. We would divide both sides by 5, and x would equal 20. That's our answer. So it says 5, 10 is the same thing as 10 to 20. Which makes sense. Okay, does anyone have any questions about how that first one works? Okay. Again, you can think of it just as a fraction again. This is 5, 10, so it's 5/10 if you want to think of it that way. Equals 10, 20, or 10 to x if you want to think of it that way. If you want to just rewrite them, you can do that. Otherwise, if you just want to solve them the same way and multiplying your means and extremes, that's totally fine as well. Mitchell, can you help us with the second one?
Sure. You do 3 times 100 and you get 300.
Okay, so multiplying the means.
Yep. Equals 25x.
Those are the extremes, the ones on the outside of the extremes. Got it?
And then you divide 25 on both sides and you get 12.
X equals 12. Sounds good to me. Tyler Mancuso, the last one. Okay. Say it again. Oh, so you're thinking about this as being 5/2 equals. You want to try it this other way instead? Okay. Let's just think of it that the means are the guys on the inside, the extremes are the ones on the outside. So if we multiply the means, that'd be 20, yep. And multiplying the extremes, okay, now what do we do? X equals 4. Alright. Thanks for that, Tyler. Okay. These last 6 problems, the last 6 problems that are up here, is basically what your homework's going to look like. Now, how long does one of these problems take?
Like 5 seconds.
A minute?
Like 5 seconds.
Would you say less than a minute, probably? Would you say 30? 3.5 minutes? 3.5 seconds? Okay. Here's what I do want you to do, though. For every single one of these problems, we did show some work, didn't we? We basically wrote the cross product thing here. Then we divided, and we did get some answer, okay? That's what I want you to show for your work for each one of them. Whether it is written in fraction form, or whether it's written in ratio form, that's what I'm going to expect for you guys to do in your homework, okay? I think it's important for you guys to remember what a mean is, what an extreme is. There might be a quiz at some point. It is important that you guys do glean and understand what means and extremes are, and maybe be able to write out a definition for the definition of the cross product property. Okay? Basically what that means is that the product of means is equal to the products of extremes. Your homework today, it's going to be a front and back page, but how long does each problem take?
30 seconds.